Welcome back to a new lesson dedicated to learning C# programming from scratch. In the previous video, I taught you what variables are, how we declare, assign, and initialize them, and finally, how we use their values. There is one more thing that I need to specify before I start explaining each variable type. In the previous lesson, I said that you can name your variables anything that you want, but that is true only for the most part. There are actually a few reserved C# words that are part of its syntax and they cannot be used as variable names. Here is a list of these reserved keywords. Now, let's delve into types of most used variables, explaining them one by one. Let's remember from the previous lesson that a variable is just a name associated with a memory location, and that a variable type defines the amount of memory required and the operations we can apply on the variable. So, the first variable type we are going to talk about, it is called int, and it is a short name for integer. If you remember from math, integer numbers are numbers that are whole. They do not contain a decimal part. Example of such numbers 0, 5, -5, 200, etc. An int variable requires a minimum of 4 bytes or 32 bits, and it can store values from minus around 2 billions to around 2 billions positive. This is a graphical representation of how an int variable is stored inside RAM memory. As for the most numerical variables, you can notice that the first bit is used to represent the sign of the number, 0 representing a positive number and 1 a negative one. The rest of the bits are used to store the binary representation of the integer number. This is the way we declare and initialize an int variable. As we will later learn, if we try to assign a value that is outside of the minimum and maximum range an int can store, we will get what is called an overflow exception. The next variable we are going to learn is called char, and it is a short name for character. It requires 16 bits or 2 bytes of memory, and it can store values ranging from 0 to 65,535. It may sound odd that we are giving to variable that stores characters a numerical value, but actually each character has a binary representation that can be converted to a number. However, we cannot directly assign a numerical value. If we want to do so, we first have to convert the number to a character. This is the graphical representation of how a char is stored in memory, and this is how we declare and initialize a char, both with a character or a number. It is important to keep in mind that the char variable, although it can hold text letters, it can only store a single character. As we will learn later, if we want to store more than a single character, we use a variable type called string. Next, there is the float variable type, which is a type that can store real numbers in floating point, meaning negative and positive numbers that have a fractional part. It can store fractional numbers with a precision of 6 or 7 decimals in the range of 3.4e raised to the power minus 38 and 3.4e to the power 38. As with the int type, the C# compiler allocates 32 bits of memory for a float variable. However, because they have different behavior, so is the representation. As you can see, the first bit is used to indicate the sign of the stored number, if it's a positive or negative value, while the next 8 bits are used as an exponent. This exponent represents the power to which the stored number must be multiplied. Finally, the next 23 bits are used to store the fractional part, of which I said that needs to be multiplied with a power exponent. These 23 bits are called a mantissa. As an example, if a variable contains the value 3.4e at power 38, the sign bit will be 0, which indicates a positive number. The 23 bits mantissa will contain a binary representation of number 3.4, and the 8-bit exponent will contain a binary representation of 10 to the power 38. You can notice that we represent real numbers using scientific notation. This system allows us to represent any number utilizing a single digit to the left of the point, an unlimited number of digits to the right of the point, and an exponent using a power of 10. When you calculate the real value of the number, we multiply the number, which I said that it is called mantissa, with the value of 10 to the x power, where x represents the exponent. For instance, number 31415e plus 4 equals to 31415.0 or 3.1415 times 10 to the power of 4. This is the way we declare and initialize a float variable type, and you notice that we add an f after the numerical value, because if you don't, the number will be treated as a different kind of real number variable called double. Double is a variable type that also holds real numbers, but with a precision of 14 or 15 decimals in the interval 1.7e minus 308 and 1.7e plus 308. It requires 64 bits or 8 bytes of memory in order to store a value. The following image illustrates the graphical representation of a double variable type. You should note that the float in the double variable types are floating binary point types. In other words, they represent a number like this. The binary number and the location of the binary point are both encoded with a value. Decimal, on the other hand, is a floating decimal point type. In other words, it represents a number like this. Decimal variables require 128 bits of memory or 16 bytes. Because it's a floating decimal point type, it stores numbers with a greater precision but with a smaller range. This makes it the most suitable kind of variable in applications dealing with financial values or any software where precision is crucial. Decimal variable type can store values between 7.9e minus 28 and 7.9e plus 28. If you want a numerical real literal to be treated as decimal, use the suffix m after the numerical value. Otherwise, as in the case of the float variable, the number will be treated as a double. Next variable on the list is a byte variable type. A byte actually stores exactly what its name states, a single byte, so it requires 8 bits or 1 byte of RAM memory. It can store values ranging from 0 to 255, and we assign the numeric value directly. Because its minimum value is 0 and it cannot store negative numbers, it does not use the first bit as a signed bit. Thus, all the 8 bits are used to binary represent the numerical value. These are the 6 base numeric types in C#, also known as primitive types. There are a few additional variable types dedicated to storing numerical values called type modifiers. They are sbyte, ushort, uint, and ulong. They are similar to their synonym variables, with the only difference that the s comes from signed, while the u comes from unsigned. So when we say a uint means unsigned int, and it is just a regular int variable but whose signed bit is also used to store the value. This means that it can only store positive numbers but in a wider range than a normal int. Anyway, you should not concern yourself with these, they are rarely used and only in specific requirements. The next type of variable is probably the most simple of all. Its name is bool, and it's a short naming for boolean. It is not a numerical variable, it doesn't have a maximum range, it can't produce overflow exceptions, and it can only contain 2 values, true or false. They are used only in logical expressions. This is the way we declare and initialize a bool variable. Then we have a new variable type called string. I was just saying that the char variable can only contain a single character. String, on the other hand, can contain theoretically 2 billion characters, although net doesn't allow any variable to be over 2 gigabytes in size, and the string uses 2 bytes for each character, which practically limits you to around 1 billion characters. Anyway, long talk short, more than enough for what you will ever need regarding text. This is the way we declare and initialize a string variable. You can notice that unlike char, where we surrender the value in single quotes, string uses double quotation signs around the value. The last type of variable we will discuss today is called object. It is a special kind of variable and it is the parent of all the other types in net. This means that all other variable types are derived from this object type, And this means that we can initialize an object variable with any kind of value we want. This is the way we declare and initialize an object variable. In the next lesson, we are going to talk about overflow exception and the errors of the calculations involving real types, as well as the differences between value and reference types, nullable types, and other topics. Until then, bye!